everyone. Welcome to day 3 of CogX. Good morning. I hope that everyone had a lovely evening last night, whether you were watching the first 2 days of CogX or whether this is your first day. A warm welcome to the final run of programming here on the cutting edge stage. My name is Gemma Milne. I'm a science and technology writer, author, and podcaster, and I'm going to be your MC for today, taking you through the many wonderful sessions. This is a packed day on this stage, and many wonderful sessions that we have coming up. Speaking of which, we've got our first session this morning kicking us off. It's called A Glimpse into the Future with Science Partners from Ahren. And I'm going to introduce you to the moderator of the session who's going to take it away. Please join me in welcoming founding and managing partner of Ahren Innovation Capital, Alice Newcombe-Ellis. Thank you very much.
Good morning. So I'm Alice, I'm founding partner of Ahren, and I'm privileged to call my partners a special group of Cambridge University's finest minds and most successful commercial scientists, including Sir Shankar and Professor Steve Jackson. You'll hear more from them a little later. Could we have the first slide, please? Two years ago, I visited the NASA Space Center in Houston. It's an immense structure, and in the stunning gallery, you can gaze up at the stars in wonder and awe of what human endeavor can achieve. People often ask me what was the catalyst for setting up Ahren. For me, that was it. I often think back to that moment with particular pertinence at this difficult time. What can our collective human endeavor and ingenuity achieve? What does the future look like, and how can we each contribute? The answer will be different for every one of us, but for us at Ahren, we set up in order to help create that future, to nurture and mold advances that will have a positive impact for all of us. At Ahren, we believe we're at the cusp of a period of possibly the greatest acceleration in progress and change that the human race has ever seen, powered by technology. Today, we're going to give you a glimpse of what we believe that future will look like. But first, for those of you not familiar with Ahren, I wanted to say a few words about us. Ahren focuses on 4 domains with one overarching theme: to invest at the intersection of deep tech and deep science in opportunities that are transformational and highly commercial. That intersection is an operative word. We believe wholeheartedly that the future will be cross-domain. We define our own mission and follow our own agenda. We understand the things we invest in and insist on an edge in order to have a right to invest. Our edge can be complexity, understanding in spaces others can't access, seeing what others don't, or contribution, being able to add genuine value. We believe we have 5 key differentiators. First, my science partners are intrinsic to our model. Their prior technologies are today worth over 100 billion combined. We pair this with sharp and dynamic investment talent to give us an edge to source, diligence, and scale deep tech, deep science companies. I've been overwhelmed by their commitment to Ahren's success in sourcing, in nucleation of opportunities from scratch, in the all-important deep diligence of deep tech companies, and in mentoring and support they provide to our founding entrepreneurs. Entrepreneurs come to us as a group they trust and respect, and a group that can have a differentiated impact on their success. Second, we accept risk, considered highly rewarded risk. We do not chase lower-end, lower perceived risk opportunities that we believe by definition erode returns. We invest in groundbreaking companies that will penetrate or create massive markets. Third, we don't just invest, we build, applying Clay Christensen's theories of disruptive innovation. We actively support nascent companies, or even nucleate companies from scratch, to turn a big idea into an even bigger commercial reality. Fourth, we have value corporate and strategic, as well as pure financial LPs. They're very important to us. We have deep relationships where we help ensure our LPs are the disruptors, not the disrupted, in the changes that lie ahead. And they provide invaluable support for our portfolio company teams, with pilots, access to networks, insights, and in some cases, potentially access to billions of customers worldwide. Fifth, we treat our entrepreneurs well, motivating and incentivizing them to succeed. We're very proud of the teams we've invested in to date. Each of our companies solves a critical problem, a limiting factor to transformational progress, with a solution that has the potential to disrupt a market. And as Ahren, our values are something we take very seriously. In sum, we feel we have a differentiated model to support exceptional entrepreneurs. And now I would like to hand over to Steve to give his perspective.
Great, thanks Alice. It's been a huge pleasure and a great privilege to be part of the Ahren Science team over the past 2 years. Working with Ahren is allowing me to use my insights and knowledge in the realms of human biology, genetics, and platform technologies to identify exciting new scientific and technological opportunities that have the potential to change the world for the good. Moreover, it's been fantastic working together with a group of accomplished and highly passionate individuals who are excited about not just their own domains of science, but the intersections between these and others. Because as we're all aware, in many instances, the most transformative and impactful developments in science arise at such interfaces. And in this regard, I found it tremendously enlightening to learn about so many areas outside of my own primary areas of expertise, and to connect up with the passionate scientists involved in Ahren and the entrepreneurs that we're interacting with, who are coming to us or whom we're finding. And then, of course, working with them to help build their exciting new businesses. Now, one of the key things about Ahren is that we don't just sit back and wait for things to happen. We're out there continually, actively looking for new opportunities, and in many cases, identifying opportunities before they come to us. And of course, then when we identify or are approached by scientists and entrepreneurs with aligned ideas and discoveries, we actively work together with them, in some cases very early on, to evolve and nurture these ideas. And in these kinds of ways, we're helping to craft the big visions, the types of opportunities that you'll be hearing about from us today. A little bit later on, I'll provide a recent example how we identified one exciting new opportunity, and that led us to nurture the development of a new company, which is now moving forth with its vision.
Thanks, Steve. So now, on to the future. As a group, we're constantly thinking ahead, never resting complacent or sitting still. We want to understand before others believe. These are the few of the domains that we're very excited about, particularly at this time of change. And if you have developments in these spaces, please feel free to reach out. So Shankar and I are going to provide a background deep dive on a couple of technologies, their limitations, and our vision of the future in each of those spaces. Over to Sir Shankar.
Thank you, Alice. Well, I've been in Cambridge a while, and in Cambridge, we think about DNA quite a lot. And in the, could I have the slides back, please? Thank you. In the figure here, you'll see the double helix structure of DNA, which was solved by Watson and Crick in Cambridge in 1953. Now, DNA is fundamentally an information molecule, and that's going to be at the heart of what I'm going to talk to you about today. It is composed of a 4-letter code, G, C, T, and A. And the basis for the code shown to the right here is the fact that the letter G can communicate with the letter C, and the letter A can communicate with the letter T. And this pairing, called Watson-Crick base pairing, is what you see down the central stack of this double helix. Now, this is the molecular basis for what we call the genetic code, and it is fundamentally the code for all living systems. Now, I'm going to talk to you about the fact that we are going through a revolution in DNA at the moment. And on this slide is marked out 3 distinct dimensions in which we're seeing transformation. The first is reading the code which I've just described. This is often termed sequencing because it's about detecting the order in which these letters are arranged. And for example, in the human genome, there are 3.2 billion letters arranged in a particular way. Now, the technology for reading this code has become about 10 million times faster and cheaper over the last 2 decades. And it will get even faster and cheaper in the future. Now, this is driving the sequencing of human genomes on a population scale and beyond. And primarily at the moment, this is being used to transform the area of genomic medicine and personalized medicine. And it's having a major impact in the areas of oncology, rare genetic diseases, and infectious diseases, to name but a few. And we're really just at the early stages of this transformation. On the bottom left, continuing this analogy with the alphabet, is the word editing. It is now possible to go into cells and make precise changes to the letters of the genetic code via a collection of technologies that are referred to as genome editing. And we're at the very early phase of seeing what's possible here. Examples of applications will be the ability to re-engineer cells for cell-based therapies. On the bottom right is the word writing. The ability to synthesize genes and synthesize genomes is going to be transformed over the next 20 years. In fact, at the moment, this is lagging behind the ability to read. So we can read faster than we can write. But over the next 10, 20 years, the ability to write DNA code will be transformed. And this, amongst other things, will allow us to design and write genomes to order. Now, staying on this slide for a moment, I want to return to the idea of DNA as being fundamentally an information molecule. Now, it has been shown that you can actually store digital data in synthetic DNA sequence. In fact, a gram of DNA can store more than 200 million gigabytes of digital data. It's even been estimated that a shoebox of DNA could store everything that's ever happened in the history of our world. So therefore, DNA is arguably the most volume efficient way of storing digital information. Now, we have sequenced the genome of the woolly mammoth, and that demonstrates just how hard-wearing and long-term this method of storage will be. And as we improve our ability to write and read DNA cheaply and quickly, I believe DNA will become a method for digital information storage. And as we also adapt our ability to dynamically alter aspects of the coding features of DNA, it will also become a mechanism for dynamic information storage and perhaps processing. Now, on the next slide, I'm going to introduce yet another dimension of coding in DNA. I'm going to introduce the word epigenetics. I've described the primary code of DNA as being the ordering of the letters that go through the middle of that double helix. Now, you'll have noticed that the helix has two grooves. I'm going to draw your attention to a groove that was called the major groove. That's the larger of the two. Now, the major groove has features that project not inwards into the helix, but outwards. And these features are recognized, and in a sense, they are read and interpreted by machines in biology called proteins. And the way in which they interpret what they read in the major groove can determine whether genes are switched on or switched off or somewhere in between. Now, there are dynamic chemical changes that occur on the DNA letters that project into this major groove and present yet another dimensionality of information, and this is dynamic information. So this information layer is critical for determining the program that dictates how all the genes are collectively in a state of being active or inactive or in between. And this determines the overall characteristics of the cell or the state of the cell. Now, this is profoundly important when a stem cell differentiates into very specialized cells, for example, skin cells or heart cells, liver cells. Each of these cells has the same genome, but the epigenetic programming is different. They have different sets of genes in different states. So the epigenome is absolutely critical for defining states of cells. And if you change the epigenome, you have the capacity to reprogram cell states as well. Now, we have a portfolio company that has a technology for detecting these changes in DNA floating around in a blood sample. And at the moment, that's being used to detect early stages of cancer. So disease states also manifest in changes in this other informational layer called the epigenome. Now, in a moment, I'm going to hand over to Steve, because there are ways of manipulating the epigenome to alter cell characteristics. And Steve is going to tell you about a specific example where we've done it. I'm going to hand over to Steve.
Great, thanks, Shankar. It turns out that one of Ahren's other portfolio companies has developed an algorithm to determine the groups of transcription factors that bind to DNA and guide this genetic information, how these transcription factors are able to, through controlling genes, turn one cell type, say a fibroblast, into another cell type, such as a cardiomyocyte. Importantly, without the cell needing to transit through a so-called stem cell state. So it only takes a moment of reflection to realize how transformational this opportunity is. The ability to transform one cell type directly into another. This technology can now do in a matter of minutes what it's until now taken researchers years of trial and error to do. Now, this, of course, is fantastic science, but it's not just cutting edge technology, it's highly commercial. In the medical arena, for example, just one cell type, the cardiomyocyte, represents a multi-billion-dollar market. Furthermore, the same technology and approach can be applicable to other cells with therapeutic potential in a range of other areas. Just for example, in osteoarthritis, certain forms of blindness, and T-cell therapies. Now, the way this company arose provides a very interesting and I think great paradigm for the Ahren model. In this case, I came across a junior researcher at a conference who was talking very excitedly about his compelling ideas and data. And in parallel, it turned out that his discoveries had also come to the attention of Savanki Ramakrishnan, another Ahren Science Partner who's based at the MRC LMB in Cambridge. Now, out of our ensuing discussions with the entrepreneur, it became really clear to us that there was truly a very exciting opportunity here. And over the course of just a matter of months, I and others at Ahren spent quite a lot of time with this scientist entrepreneur and his colleagues discussing the opportunities and helping shape the goals and the vision for a company. Now, in getting the company off the ground, I served as an interim chair of the board, I think, which helped steer the company in the right directions. And it's now wonderful to see this company thriving and growing. So this is how we work at Ahren, and I think that kind of model provides a great paradigm for how we can measure other companies now and in the future.
Great, thank you, Steve. So now shifting gear a little bit. As most watching will know, the most significant breakthroughs in AI in recent years have come from a form of machine learning called deep learning. The following will be basic for a number watching, but to set the stage in order for us to then talk about limitations and opportunities going forward in the space, I wanted to explain the following. So a deep learning system learns to map some inputs, say pixels in an image, to some output, say labels for objects in the image. It's called deep because that mapping is composed of a number of layers. The way that it works is actually rather straightforward. Initially, the mapping from input to output is random, and the system makes many mistakes. But each time a mistake is made, the connections in the system are tuned ever so slightly, so it's less likely to make that same mistake again. Over time, and seeing millions of labeled examples, it learns to classify the majority correctly. Importantly, it also ends up generalizing, meaning that if you give it an image that was not in that initial training data set, it will correctly classify that too, so long as it's statistically similar to the others. But as we know, next slide please, deep learning has a number of important limitations. It requires massive data sets for training. It's essentially a black box, with the programmer even unsure why the results come out as they do, and it's easily tricked. In the now famous example, with the right tiny perturbation, we can get the images to be classified as anything we want. As we see here, this poor panda is being classified as a shark or a goldfish. The worst part of all of this is that the algorithm is confidently wrong. There are more subtle, potentially invidious social consequences too. For example, current predictive algorithms on social networks were in theory designed to provide the user with content they wanted, which was relevant to them. But if the objective function of the algorithm was in fact defined as maximize click-through revenue, that's actually a rather different thing. The corollary of this was that a few lines of reinforcement learning code actually changed the user's preferences, effectively changing the user. So where the standard model of AI seems to go wrong is that its success is based on the extent to which its outcomes meet its objectives and that there is a clear goal. But the reality is that we do not know how to properly define an objective, and it's this that can lead to unintended consequences. So moving on to solutions and investment opportunities. Beneficial AI is founded on the principle of building machines that, rather than using the typical Markov processes underlying reinforcement learning, are instead explicitly uncertain about their objective and indeed guaranteed to help with our actual preferences. The way it works centers around three tenets: altruism, solving the instrumental goal issue, where a machine will not enable itself to be turned off at all costs to meet its defined objectives; humility, being explicitly uncertain of what human preference is, obligating cooperation; and observation, the premise that the ultimate source of accurate information is observing human behavior rather than taking a literal interpretation of our poorly chosen words defining an objective. If we get this right, we can achieve the economic upside of AI without the societal cost. As our science partner Zubin Garamani explains, it has become fashionable to compare AI to human intelligence and to envisage Terminator-style AI robots. But we feel we should question this. The human brain and AI are very different. The brain is complex and remarkable, particularly its energy efficiency, able to run on the same energy as a 20-watt light bulb. However, the human brain stores very little information about the world, of the order of 2 terabytes, about the size of a hard drive. Also, we know from cognitive science, human reasoning sadly is flawed and our perception is limited. On many tasks, humans are much better than us already. What this tells us is that we should not think of the goal of AI as mimicking humans. Instead, we should move away from this human-centric view of AI to focus on the potential for AI to solve problems that humans are not good at, to complement human intelligence. This is a positive message. Examples include optimizing the transportation network of a city in real time, extracting patterns in biomedical data sets with millions of genomes, screening molecules for their therapeutic properties, or detecting fraud or harmful content online. This is what Ahren's focused on, and if we get this right, the opportunities are profound. Now, a brief glimpse further into the future. Ahren is working on automating machine learning using machine learning to create a system that is unbiased, does not require large data sets, and can explain its decision-making. We believe this could be transformational and has the potential to open up vast markets where previously AI was not allowed for regulatory reasons. Another breakthrough Ahren is working on is yearly charging. So if you shine a laser light at a microcavity, the atoms interact with the light, kicking off a quasi-particle, a polariton. These quantum particles are correlated. This means they spin and move in the same direction, properties of a superfluid at room temperature. If you use polaritons in this way in a transistor to store, switch, and send information, instead of using electrons, which constantly bump into each other, causing energy dissipation, you can create near zero energy loss. The commercial implication? You could charge your iPhone once a year, not once a day. I think a few of us might like that product. Today, encryption, securing messages, works by multiplying together a large number of prime factors to create a key. But as quantum computing progresses, this has the potential to be factorized, i.e. unentangled, in a split second. This means that everything encrypted on the internet, all of your banking details, every message you send, and every message you've ever sent, may become instantly available. At Ahren, we've invested in a company working on the solution using a fundamental property of physics, that if you have an entangled photon pair, measure the state of one photon, the state of the other changes, no matter how far away, even on the other side of the universe. They use this to send keys securely via satellite and enable unbreakable quantum encryption. We also have projects relating to manufacturing in space, bioengineering of trees to remove pollution from the air, contribute nutrients to the soil, and benefit the environment, animal cognition and communication, and design of cutting-edge immediate alert systems, including smart biological sensing of one's environment. Given the pertinence of this at this time of COVID-19, I'll say a few words on this one. Our vision is to create a genetic monitoring system to A, automatically and instantaneously detect whether there are pathogens in the air, preventing their spread. B, discover a virus endemic in animals, say birds, bats, or pigs, before it jumps into humans. And C, detect your immune response to such a pathogen, checking your autoantigens, what it is you're exposed to that causes you to become autoreactive in your immune response to the environment. Our vision is that it would be extremely fast, cheap, tiny, and integrated into a software to link to a network of many millions or billions of sensors worldwide, exchanging information within seconds. Ideally, we could invent non-invasive body sensors, enabling 24-hour monitoring. In sum, we believe a generational opportunity exists, and that's why Ahren was founded. We empower and support exceptional entrepreneurs with exceptional technology to prosper, succeed, and change the world for the better. It doesn't feel right to talk today without acknowledging the situation we're in. The global scientific effort and collaboration has been tremendously impressive. I have confidence in our society to meet this challenge, and at Ahren we have been deeply committed to playing our part. We do not think there's any quick solution to this problem. It may be many months before we achieve any sense of normality. However, it is not deterministic. We as a society will determine the outcome in our actions from now on. One must in no way diminish the terrible suffering of the moment, but I do feel, in relation to the pandemic at least, we must consider that we may have been spared an even greater tragedy this time, and must use this as a warning not to go back to our old lives unchanged. My great hope in all of this is that we can use this crisis to serve some positive purpose. I hope a shift from self-interest towards acting as a humanity will not only happen, but that it will continue once we've emerged from the other side. Perhaps we'll be able to use frameworks and connections without borders to tackle the other pressing needs with which we're faced, including true racial equality, not just nice words, preserving our precious planet, preparedness for any bioattacks, beneficial AI, and ensuring global food supply. While those perhaps used to sound like vague, faraway sounding words, I think for many they have now hit home. After all, what's the point of making money if we have no health? Why would we travel across the globe unnecessarily if we destroy the precious earth we live on? And who's going to be hoarding power if humans no longer exist? There are a few rare times when one is called to step up and work together for the benefit of humanity. This feels like one of those times. Let us all be able to look back and say, when it mattered, I played my part. And for those of you like us seeking to create the future using deep tech and deep science, I'd ask that you each ask yourselves, what can you do in all of this? What have you always dreamt of? What do you want to be remembered for? And how can we at Ahren help you to achieve it? The collective energy, intellect, and talent of those watching is profound. Let's act together using that human endeavour and ingenuity of which we spoke at the start to achieve something of which we will all be deeply proud. Thank you. And that ends our session today. We weren't able to do the Q&A, but please feel free to connect with us, and hopefully that last slide will stay up so you'll know how to do so. A warm thank you to Sir Shankar and Steve for joining us as well today.
You're welcome.
Thank you very much, everyone, for that session. That was absolutely fascinating and such a brilliant way of kicking off the day. We're now going to have a little break before the next session on this stage, on the cutting edge stage. The next session is at 12 o'clock, And the title is going to be Privacy Preserving Machine Learning, Having Your Cake and Eating It. An interesting question that I think lots of people are going to be thinking about a lot over the last 2 days, but obviously continuing into today's programming across all of the stages. Speaking of all the stages, we have many different sessions still coming today. So many different speakers from so many different industries. So while you have a little break on this stage, go and have a little look at who else is speaking. Make sure you have a little look at the expo. There's also some networking rooms that you can get involved with, and of course you can join the conversation on Twitter and other social media channels using the hashtag. Thank you very much for now, and I'll see you again at 12.
Want access to more CogX videos? Subscribe now for free at cogx.co.